Let ln of 5 be equal to x and ln of 7 be equal to y. Write each expression in terms of x and y. All right, so let's look at example A here. It says ln of 35. Well, what we're going to do very simply is to express this as a product, right? So in other words, we're going to say that this is ln of 5 times 7 because we want to use the 5 and 7, right? 35 is not helpful to us here because we don't have something that represents ln of 35, but we do have ln of 5 and ln of 7. So now if we could just rewrite this to turn a product into a sum, and I think we can because we have a rule that says what? Products can be expressed as sums. So let's write this as ln of 5 plus ln of 7, right? So we write the log down twice and put the two factors of the product next to the ln. So we're taking the ln of 5 and the ln of 7, and the multiplication symbol becomes a plus sign, right? Then from there, ln of 5 we know is x, so we'll have x plus ln of 7, which we know is y. So x plus y is the answer for A. All right, let's look at B. For B, it's the ln of 1.4. So that's a little bit challenging because we may not be familiar with the decimal representation of certain fractions. But I'll tell you, since they're giving us ln of 5 and ln of 7, I bet 1.4 is either the fraction 7 over 5 or 5 over 7. Now the fact that 1.4 is bigger than 1, I'm going to guess that it's 7 over 5. So what happens if you divide 7 by 5? Well, 5 will go in there evenly once, leaving you with 2/5 left over, and 2/5 is 0.4, so this is 1.4. So really that's ln of 7/5. So let's rewrite it as ln of 7/5. And why do we want to do that? Because then we can use this rule, which says what? The log of division can be written as the subtraction of two logs, right? So we'll be able to say ln of the top number, 7, minus ln of the bottom number, 5. And then we know that ln of 7 is y, and ln of 5 is x, so we have y minus x. All right, let's look at C then. C is ln of 49. Now, again, we have to relate this to either 5 or 7, and I know 49 is 7 times 7, so I can say what? ln of either 7 squared if I want to, or I could even say ln of 7 times 7. If I say ln of 7 squared, this 2 can come out in front, and it'll become what? 2 times ln of 7 using this property that we have here, which says the exponent can come out in front of the log. And then if I do that, that's just what? 2 times ln of 7 is y, so 2 times y is the answer. So that's one way to get the answer. The other way to get the answer would be to say what? If I had gone ln of 7 times 7, I could have said a product becomes a sum, right? I could have said ln of 7 plus ln of 7. That's how you rewrite a product like this using that property here, property 1, right? If we did that, ln of 7 is just y, ln of 7 is y, so y plus y again gives you 2y. So it doesn't matter how you get there, in the end, all roads lead to the answer here. All right, and then the final part is B. So for B, I probably want to rewrite it here as ln of, I want to turn that third root into a rational exponent. So as I rewrite it first as the third root of parentheses 5 over 7, right? Then I can rewrite that, remember that would be to the 1 power, the 5/7 would be to the 1 power. And remember I can swing this 3 around as the denominator of that 1, saying that it'll be ln of 5 over 7 to the 1/3 power then. And then the power can come out in front, right? We know we're allowed to bring exponents out in front here. So it'll be 1/3 ln of 5 over 7. And then remember, this type of thing can be evaluated with our second rule in this list, right? Which says that the log of a fraction can be written as a difference, right? So we can say ln of 5 minus ln of 7. So we'll go ahead and rewrite that as 1/3 times ln of 5 minus ln of 7. Notice how I put a parenthesis around all of that, because the 1/3 is multiplying everything, right? And then finally, ln of 5 minus ln of 7 can be rewritten, because I know ln of 5 is x according to our opening statement in the problem, and ln of 7 is just y. So this is the same as 1/3 times x minus y. And that's our final solution.